Okay, um, based on the request which I received, um, routing. Uh, yeah, let me read this definition just a bit. Routing is a process used to predict the temporal and spatial variation of a flood hydrography as it moves through a river, a reach, or reservoir. Now, basically, this is a process where you can predict um, the floods throughout the river channel or throughout the whole entire uh, trajectory of floods as it moves from, let's say, upstream to downstream. Now, this whole process is more like simulating. You are simulating given the inflow hydrography or given the inflow floods at a particular point, you can simulate it downstream. Now, what do I mean by simulating it? So you can say, for example, if you have this amount of flood or this amount of water at point A, what will be the amount of water at point B? And then how long will it take to reach that point? So that is what basically is, and it is very important because it is used or it can be used in uh, risk management, disaster risk management, okay, or flood management, or even in planning, because then you know that okay, if we receive this amount of water at point B, what are the consequences as water reaches downstream or point B? So then it can be used in planning. Okay, you can then put preventive measures because remember floods are detrimental. Sometimes they can damage roads, they can damage property, they can infrastructure generally they can be infrastructure can be damaged. So then flood routing is very important because then you are able to know mitigation measures that you can put. So it is very important in flood risk management. Okay, it is used for flood forecasting. Now, uh, of course, there are different methods, and I guess here normally we are for this particular lecture is just focusing on hydrologic uh, flood routing. Okay. Now there are important key things here that you should know: storage, inflow, storage, of course, outflow, okay, and also elevation. Now, these are the key important things that most are used in this lecture for you to be able to drive or for you to be able to simulate the the flood. Okay. Now, there are also some common or key or some terms which are used, uh, terms like attenuation, okay, terms like lag, okay. Now, attenuation is basically the difference between the two peaks of the waters, okay, or of the flood. So at point A, what was the peak, and at point B, what what is the peak? So when you the difference between the two is simply the attenuation, and then when you talk of lag, it's basically simply the time it takes for that transition, okay, from one peak to the other. That is just the lag. Okay. Now, There's this okay, here they're just mentioning about something that we said, hydrologic routing and hydraulic routing, but basically here it's just about hydrologic. Now this is the equation, this is basically the continuity, based on the principle of continuity. So of course, the parent equation, the parent equation here, okay, here, this is the parent equation here, which can be then manipulated. So this is basically based on the functions, okay, and this is done by integration, okay. So there is a function, storage to um, storage to inflow function. There is also actually a um, storage to okay, sorry for that, I received a friend now. Okay, also storage and the elevation, so those are combined to come up with this equation. It's a simple equation, this same one, we have this one. So now going straight into the calculation part, because I think we have done a bit of introduction on what is routing and what is involved and why is it important. This equation, these this part here, this part here, this part here, these are known variables, something that we know, because there is inflow, outflow, time, and storage. Then it was just rearranged and grouping the known variables one side and the unknown variables the other side. Okay, so this side, these are the variables which are not known. Okay, so um when solving normally you'll be given the inflow hydrography, okay, and perhaps time and maybe elevation and all those, but then from those you can build up different relationships. So this is basically, it's called indicative storage, okay, indicative storage. So normally there are a lot of methods that you can use when solving, okay, but the easiest one, um maybe you can use a graph or interpolation, linear interpolation, okay, which we'll explain later. So basically, on your graph, on your graph, let me see if I can have a plane. Okay, so basically on your graph, you are going to have elevation on your y-axis, and then you are going to have your indicative storage on your primary x-axis. Okay, your indicative storage. Okay, here. Then on the secondary x-axis, you're going to have outflow. So this is simple and straightforward, because once you plot, then you're just coming here and get the values. Okay, now normally the information that you're going to be given, you need to work with it, you need to calculate so that you come up with relationships. Okay, you come up with the values for indicative storage and um, q, normally q you might be given, as you'll see later. Okay, so now let's say first thing, you plot indicative storage versus elevation. Okay, so let's say you have something like this, and also you plot elevation versus outflow Q, and then you have maybe something like this. Okay, now when getting the values, okay, as you see when we start solving, okay, then the process continues. Okay, let me record another one, and then I upload where I'm now. Maybe we can start solving so that all these things are understood.